Hidden inside every single device you own, there's this tiny, intricate city made of copper. For decades, we've built these cities by carving them out of a solid block. But what if we could just print them? Today, we're going to look at a technology that's doing exactly that.
So, what you're looking at here is a printed circuit board, or a PCB. And yeah, you've definitely got one in your pocket, on your desk, probably even in your car. Think of them as the hidden nervous system for our entire modern world. These incredibly complex highways of copper that tell electricity where to go, making everything just work. Which, of course, begs the question, how in the world do you make something so precise on a massive global scale? Well, the answer is kind of surprising. For decades, the process has been less about building something up and more about, well, destroying it.
So let's dive into the old way of doing things, a process that's all about starting with a solid sheet of copper and basically carving away everything you don't need.
Yeah, seriously. The traditional method isn't about building a circuit at all, it's about carving one. It's what we call a subtractive process. You start with a board that's completely covered in copper, then you use all these harsh chemicals to dissolve or etch away everything you don't want, leaving just the tiny circuit path behind. And get this, when you actually break down the time, it's wild. The actual etching part, the part you'd think is the whole point, that can be over in just a few seconds. But then you're stuck waiting for almost half an hour just for cleaning and drying. And the final, crucial step, treating the surface so it doesn't rust, can take anywhere from 4 to 10 hours. The takeaway here is pretty simple. The traditional method is slow, it's complicated, and it's incredibly wasteful. You literally throw away most of the copper you start with. I mean, this process has been screaming for an upgrade for a long, long time. Well, that upgrade is finally here, and it's a breakthrough that doesn't just improve the old method, it flips it completely on its head. Remember that whole subtractive thing, carving stuff away? What if instead you could simply add? Instead of carving, what if you could just print the copper exactly where you need it? This is a completely new additive approach. No waste.
And this is the magic behind it all. A solderable conductive copper paste. Honestly, the best way to think about it is like an ink. A special metallic ink that, once it's printed and cured, acts just like a traditional copper circuit. And, this is the most important part, you can solder components directly onto it.
Okay, so what exactly makes this paste such a total game changer? Let's break down its key superpowers.
First off, it's solderable at high temperatures. Now this is a huge deal because it means the paste can be dropped right into existing manufacturing lines that use standard soldering methods. No big changes needed. You get these full, solid solder joints, which is exactly what you need for a reliable, strong connection. Second, it's super versatile. It can be applied using all sorts of methods, like screen printing. Yeah, literally the same basic idea used to print designs on t-shirts. This allows for incredible precision, creating these really fine, complex circuit patterns on all kinds of materials. And third, this stuff is tough. I mean, really tough. The paste creates an incredibly strong bond with whatever surface it's printed on. This test here shows a wire soldered to the circuit withstanding over 3.5 kilograms of force before giving way. That is one seriously strong connection.
So, you've got this printable, solderable, durable copper ink. That's cool and all, but what does it actually mean for the products we all use every day?
Let's start with renewable energy. This paste is a perfect fit. You can print the circuits that collect electricity directly onto the solar cells, which totally simplifies the manufacturing of everything from tiny individual cells to the massive panels that power a whole solar farm.
Or how about the world of electric vehicles? Here, it's solving a critical safety issue. The paste is used to print grounding points directly onto the metal casings of the battery packs. This creates a solid electrical connection that also protects against corrosion, which is absolutely vital for the safety and long life of the vehicle.
And check this out. This is one of my favorites. LED lighting. Traditionally, LED circuits are made on expensive copper-clad boards. With this paste, manufacturers can use way cheaper aluminum boards instead, and just print the copper circuits only where they're needed. The result? The exact same performance for cost savings of up to 65%. That's incredible. But the most dramatic impact really is in the numbers. Let's do a quick side-by-side comparison to really get the scale of this revolution. First, time. The old etching process, with all its steps, takes a bare minimum of 4 hours. The new printing process, start to finish, it's all done in under 45 minutes. That's not just a leap in speed, it's a whole different ballgame. And then there's the cost. To produce 1 square meter of circuitry the old way costs over 40 yuan. With this new paste, that cost just plummets down to between 14 and 19 yuan. It's not just cheaper, it fundamentally changes the economics of manufacturing.
So what does all that mean? It means we're looking at a minimum cost reduction of 53%. In an industry where companies fight over fractions of a cent, cutting your costs by more than half isn't just an improvement, it's a seismic shift.
This isn't just a tweak on an old process. It's a fundamentally better way to think about manufacturing. It's simpler, faster, way less wasteful, and so much more efficient. It's really a new way to build the electronics that power our entire world.
And this really just leaves us with a fascinating question, right? We've gone from this complex chemical carving process to something that's basically like a desktop printer. So if making electronics becomes this easy and this efficient, what new devices, what new ideas, what new industries are we going to